Hello my dear students, in this video we are going to prove the most important theorem of your class 9th. The name of this theorem is most important theorem. The name of this theorem is midpoint theorem and most important one. Not used only in your class 9 or class 10 math, but it has a wide range of application. Okay. So first of all you have to read the statement carefully. The line segment joining the midpoints of two sides of a triangle. The line segment joining the midpoints of two sides of a triangle is parallel to third side and equal to half of it. Here ABC is a triangle. D and E is the midpoint of AB and AC respectively. That means AD is equal to BD, DB and E is equal to C. And D is the line which is formed by joining midpoints of AB and AC respectively. So what is given person? Given person is ABC is a triangle in which D and E are the midpoints of AB and AC respectively. And what do we have to prove? We have to prove D is parallel to BC. Joining parallel to third side, that means D is parallel to BC and D is half of it. That means D is equal to half of BC. Let's take BC is equal to 10 centimeter. So half of B 10 is 5. And this is 12, then half of 12 is 6. Okay, clear? So how do you have to construct? To prove this theorem, we have to need a construction. Draw CP which is parallel to BA. CP is a line which is parallel to BA. And extend D which meets CP at point P, at point F. Okay, clear? Third, CP is a parallel to BA and extend D so that which meets CP at point F. Clear? Proof. First of all, we have to set the target. What have to prove? We have to prove D is parallel to BC. So we have to show DBCF is a parallelogram. If DBCF is a parallelogram, we can say DAB is parallel to BC. Yes or no? DAB is parallel to BC because parallelogram means both pair of opposite sides are parallel and equal. So first of all, you have to prove DBCF is a parallelogram. So parallelogram can be defined in two ways. First two ways is both pair of opposites are parallel. Both pair of opposites are parallel. First definition, and second definition is one pair of opposite sides are parallel and equal. So second definition is most important one. One pair of opposite side parallel and equal. This much portion we have to prove. Okay. So DB is parallel to CF. So we have to show if DB is equal to CF, we can conclude that DB CF is a parallelogram. Okay. So in triangle ADE, first of all we have to look at these two triangles. Triangle ADE and triangle FDE. In triangle AED and in triangle CEF, angle A is equal to angle C. How? DB is parallel to CF and this is alternate interior angle. These two angles are alternate interior angle. Okay. So angle DAE is equal to ECF. Clear? Next one is A is equal to EC because alternate interior angle. If two lines are parallel, suppose these two lines are parallel and this is the forms Z's. So these two angles are equal. Why? Because alternate interior angle. Clear? Next, AE is equal to EC. Because midpoint, this is given person and this is our alternate interior angle AIA, or you can alternate interior angle. Clear? And third one is AED equal to angle AED equal to CEF. Vertical opposite angle VOA. Both the triangles are congruent. By how? Look at this triangle AED congruent symbol. Angle A is equal to angle C. That means first is first. E is second position CE. F. By which rule? Angle side angle. ASA rule. Angle side angle rule. Clear? So by CPCT, both the triangle are congruent, so we can write down AD is equal to CF. AD is equal to CF by CPCT, corresponding part of congruent of triangle. If two triangles are congruent, all sides are equal. That means AD is first and third is equal to the first and third. AD is equal to CF. This is our but we have given that AD is equal to DB. AD is equal to DB. This is given person. This much person we have given because D is the midpoint of AB. That means AD is equal to DB. From equation 1, this is equation 1 and this is equation 2. From equation 1 and equation 2, what do we have to get? AD is equal to CF and AD is equal to DB. That means DB is equal to CF. DB is equal to CF. First of all, we have find that DB is parallel to CF, and second one is DB is equal to CF. That means DB CF is a parallelogram. Hence, DB CF is a parallelogram. Hence, DF is parallel to BC. If DH whole part is parallel, that means whole part is parallel, then small part is also parallel. Hence, D is parallel to BC. Euclid's geometry. This we have to prove. D is equal to BC. And second part is D is equal to half of BC. And DF is equal to BC because DBCF is a parallelogram. DF is equal to BC. Because this is a parallelogram, DF is equal to BC, and DF is equal to D plus EF. D plus EF is equal to BC. Clear? D plus BF, that means D plus both are equal because both the triangles are congruent. D plus D is equal to BC. 2D is equal to BC. Clear? 2D is equal to BC and D is equal to half of BC. This is our proof part. Clear? First of all, we have to need a construction. CP is the parallel to DB. Okay. So taking two triangles congruent, we have to take AD is equal to CF and D is equal to EF. Okay. So AD is equal to DB is given because D is the midpoint of AB, and we have to prove DB is equal to CF. That means this triangle, this quadrilateral DB CF is a parallelogram. Hence, DF is parallel to BC. If parallel, DF is parallel to BC. That means whole part is parallel and small part is also parallel. D is parallel to BC. And D plus CF both are equal to 2D is equal to BC and D is equal to half of BC. Okay.